this. Her Majesty took away my fear I had in chemistry and biology. You have to join the Easy World. My name is Victor Modia, a student in Italy. Anywhere you are, you can join us. Join the Easy World. Be a subscriber. Bye.
Okay, this is Her Majesty Easy World Science Channel. Today, I'm going to demonstrate for teachers two things here: how to distinguish between sodium triazocarbonate 4 and sodium bicarbonate, that's sodium hydrogen triazocarbonate 4, and also how to prepare the two standard solutions required for a certain titration, where you are asked to prepare a standard solution containing 3.8 grams of sodium hydrogen triazocarbonate 4 and 5.3 grams of sodium triazocarbonate 4. Over here you have the bicarbonate, that's the sodium hydrogen triazocarbonate 4, and over here we have the sodium triazocarbonate 4. So this is actually, I will give you the chemical test to distinguish the two. First, as we all know that this is an acid salt, while this is a normal salt, of course. Then you can use heat to distinguish the two. Action of heat on this liberates CO2, colorless, odorless gas, which turns lime water milky. That is for the bicarbonate, of course. But action of heat on this, remember, sodium triazocarbonate 4 is one of the carbonates that is stable to heat. Most carbonates decomposes on heating except that of sodium and also potassium. They are stable to heat. So if you heat this, it will not liberate CO2. That's one way to distinguish it. Then another way is that you over here, I can use these two beaker. Here should be for bicarbonate, here should be for the carbonate. So here I have, I'm going to make a solution. This is the crystal. All of them are white, of course. Most times the carbonate is more crystalline than the hydrogen carbonate. That's the, you can call the sodium hydrogen triazocarbonate for baking soda. That is, this one should be called baking soda, of course, because it's used in baking of baking powder. But it's an acid salt, while this one here is a normal salt. So I want us to see the differences between the two. The two dissolves in water, of course. Two are highly soluble, but the carbonate is more soluble than the bicarbonate. So here, you see they are all white in appearance. Remember, I'll teach you how to make the accurate measurements and to prepare the standard solution specified earlier. It's 5.3 grams and 3.8 grams of the carbonate and the bicarbonate respectively. So here we have the solution, we have the crystals of the two. I will tell you how to distinguish, because if you don't buy the correct ones, your results will be faulty. So what I'm going to do, I'll add water to each of them. You can see the two dissolves, of course. Okay. Over here, I want to use litmus paper to start with. Remember that litmus base is turned red, litmus paper blue. So I want to start with the action of litmus on each of them, even though they have not finished dissolving. But the number we need in molecules are there already. Let's be patient a bit. So I'll use a glass rod to stir, facilitate. I'll use a glass rod to facilitate the dissolution. Okay, that's it. Remember, if I use the same glass rod on the two, it is a problem. You see, this one has almost dissolved completely. So the carbonate is completely dissolved. The bicarbonate is still yet to dissolve. Like I told you that the bicarbonates don't dissolve as the carbonate, of course. Then I will use litmus paper, and also I will use a phenolphthalein. Apart from the action of heat, litmus paper can still distinguish between these two, the bicarbonates. This is actually for the teachers. As we know, they are bases, of course. A base should turn, though the other one is an acid salt, but has this basic property a bit. So base is turn red, litmus paper blue. So I'm going to bring red and see the rate at which the two will turn it blue. So I have my litmus paper. I will detach two. Yeah. So over here is the litmus. So I will insert first on the sodium carbonate. This is the sodium carbonate. If you put it, it changes it immediately. So let's see what happens if we put it on this bicarbonate, that's sodium hydrogen triazocarbonate 4. You see, it's partial, it's not changing it immediately. See, it's very slow, though it's turning it blue, but very slow. This is pure blue. This is slow again. That might not conform with what you know. Being an acid salt, why will it even have effect on this? That's another discussion for another day. Then, another thing is that I want to use phenolphthalein on the 2. We all know that color of phenolphthalein in base is pink. So this is phenolphthalein. This one will distinguish it faster for you, at least at the beginning. So if you drop phenolphthalein, this is the bicarbonate. You see I've dropped phenolphthalein. There is no color change. I'll shake well. There is no pink coloring. But if I drop it here, you see already. So phenolphthalein will help you distinguish it faster. See? So there is no changing of pink here with the phenolphthalein, but with time the 2 will turn pink. That's from my experience. You know, I do research. If I leave this tomorrow, both will turn pink, but this one will be more pinkish than this, which means you can use phenolphthalein. Is what I now discovered that does the distinguishing very easily if you don't want to heat. But if you want to heat, that is very easy. If you heat, action of heat will liberate CO2 from the hydrogen carbonate, but action of heat on the carbonate will have nothing. It is stable to heat. So at least the ways to distinguish between the 2 has been clear. If you don't do this, mind you, you have error and measure what you are told to measure, you won't get the accurate mass. So I will run it again. I say by the action of heat to distinguish between the 2, the bicarbonate liberates CO2 on heating, and you know how to test for CO2. Watch it here on my channel. It turns lime water milky. I know you already know, but to see it live, it turns it milky. Then this one on heating will not decompose. Then you can also use this action of litmus paper. The bicarbonate turns red litmus paper blue immediately and gives you deep blue, while this one turns it slowly but will still give you blue at the end, but not as quick as this. Then phenolphthalein, as we have seen, this one will give you pink immediately. That's the triazocarbonate 4, while this one will not give you anything. But I told you, on standing for a long time, this one will also turn pink, but that will take a longer time, but this will become pinkish more. So phenolphthalein is the idea you can use here if you don't know. Then you can now check what do they have in common. These 2, of course, if you add acid to any of them, both of them will give effervescence. If you add acid to any of them, if this acid, this is actually an acid, any acid, H2SO4, HCl will do that. Even though it's bicarbonate, there will still be effervescence. See, both of them will give you effervescence on addition of acid. And remember, if I add acid here, this color will disappear if the acid is enough, because that's neutralization, but we'll see the effervescence. So both will give you effervescence in the presence of dilute acid. Why? Because this is an acid salt, of course, but it still have that basic property. In the presence of an acid, this will act as a base, but in the presence of a base, this will act as an acid, of course, though it's not like it's amphoteric, but I'm telling you what is clear and what is real about them. Now, I want to teach you how to measure.
Hi, my name is Cheryl.
And I'm Jennifer.
Guess what? There's a channel called Her Majesty Easy World Science.
And do you know the best part?
It
makes science so easy. Wow.
It makes science easy, simplified, and very, very fun.
Guess what? Rocket science ain't rocket science anymore.
It's now ABC.
Like if you did science in your entire life.
Another thing about Her Majesty Easy World Science channel is that he makes available laboratory equipment and reagents.
Guess the best part? If chemistry has been hard for you, he does tutorials.
And another thing is, when you order for these things, they are high quality and they are also cheap and affordable for anybody.
If you want to order, just look at the number below the screen.
And don't forget to subscribe and hit the little notification button down below.
Don't forget to share, of course. Obviously, there's love in sharing.
Thank you. We'll see you there.
The solution B, which we are told to measure, which is to get 5.3 grams of sodium carbonate and then 3.8 grams of sodium hydrogen triazocarbonate 4. What you're going to do is that you bring your weighing balance. Here I have my triple beam balance, my electronic balance. I can't find it. They took it out from my laboratory. So here, first of all, what you do is know the weight of filter paper if you're using filter paper, but I advise you use filter paper to weigh. Anything you are going to use to weigh, if you want to use watch glass, you know the weight. This filter paper from my own weighed 1.1. So what you will do first is, remember they told you that 5.3 grams and 3.8 grams of the sodium carbonate and the sodium hydrogen carbonate respectively will be in 1 dm cube of solution. So what I'm going to do is put this on a weighing balance. It weighed 1.1. First of all, what you have to do is just you press 1.1 plus 5.3. Over here you have your 6.4. So you place this on an electronic balance and keep adding this sodium carbonate until it reads 6.4. If it becomes more than 6.4, you use your spatula and scoop the excess back until it reads 6.4. But if you are using your triple beam balance, you can just restore the reading automatically you take the reading automatically to 6.4. You see here, this is our 5. You take it to 6.4 with the weight of the filter paper until this comes back to equilibrium. So that's what you need to do. Then when you have gotten the 6.4, you want to also measure the 3.8. You can do it separately or collectively at the same time, or to stay on the safer side, you keep away this one. This is the 5.3. You keep it. You bring another filter paper, know the weight also. If the weight happen to be 1.1 again, you now just add again 1.1 plus 3.8. You have 4.9. You still do like you did. You now place this on the electronic balance and now start adding the bicarbonate until it reaches 4.9. When it reaches 4.9, you keep it. So you have gotten the two. You have measured the two carbonates separately. The other one is the bicarbonate, the other one is the sodium triazocarbonate 4. You keep them separately. What you do now is that you bring, this is your volumetric flask. This volumetric flask is a 1000. There is a mark over here. The mark is for 1000 ml. I don't know if my camera can get it. I guess so. So what you do first is, this is the already solution I've prepared. What you do is just add up to half. Just use distilled water and fill it to half. Then when you fill it to half, you can now bring 500 ml beaker and fill the 500 ml beaker up to 300 cm cube mark. That 500 ml beaker, you fill it up to 300 ml cm cube. Let's assume this is the beaker, but this is 100 ml. Just fill it up to 300 or half of the 500 ml. Then bring the 5.3 grams you measure separately and pour here, and bring the 3.8 and also pour inside that half of 500 ml. You use your glass rod and stir well. You keep stirring until the two dissolves. When the two dissolves, remember you have filled this to half. You did not come to the mark, which is 1000. When you shake it well and to ensure complete dissolution, when the two has dissolved completely, you gently bring this your volumetric flask, and now remember you have filled it to half before. You now pour that half of 500 ml to this. It will not reach up to this mark. So when you pour the whole thing, it will not reach up to this mark. It is this mark that is 1000. So you shake well to allow you mix. After shaking well, you now go and bring distilled water again. When you get the distilled water, you add it to this volumetric flask. You now add it up to 1000. Yes, you fill the remaining volume until it gets to that mark and shake it well. You are done with your preparation of B, and that's how to prepare B. Now, to calculate the concentration of this B, you know that 5.3 grams of sodium triazocarbonate 4 actually represents what? If you say the molar mass of sodium triazocarbonate 4 is 106, so 5.3 divided by the molar mass, which is 106, will give you automatically 0.05. Therefore, you have gotten 0.05 here, but I tell you, you don't have you have more than 0.05 here. Then the molar mass of sodium hydrogen triazocarbonate 4, that is sodium bicarbonate, is 84, and you measure 3.8 of it. So 3.8 plus 84, not plus either, 3.8 divided by 84 will give you 0.045. So if you say 0.045 plus 0.05, you are getting something like 0.09, which is approximately 0.1. But this is not true. This solution is not up to 0.1 or 0.095. It is not. Reason is because this bicarbonate is acidic and this is normal salt. So if you mix, since I've mixed the two, this bicarbonate is also being neutralized to completeness by this normal salt to give you more of this carbonate. So you don't just sum it up that way. It is not, because if it is 0.09, you see that your endpoint will be close to 50 or more than 50 either, because the strength of the acid they used is about 0.1 mole, of course. So if you use this and do your titration, for those that want to fudge the strength by adding up this to get 0.095, no, the strength of this is less. They use this bicarbonate to lessen the concentration and also increase it a bit. So it's a way trying to hide the concentration from you teachers. But you know what? That's the actual concentration, so that after your titration, you watch down my titration to know the actual endpoint. But if you take it as 0.09, my dear, your endpoint will be close to 40 something, and that's risky because I know what you are using is actually a burette of 50. And when it is exceeding 50, students might find it boring. So that is it. Remember, this is Her Majesty's World, your good friend over here in Nigeria. Please subscribe and share my videos. I cannot do without you. Please advertise for me and also book for a private class if you want likely questions on this titration between 3.8 grams of bicarbonate of sodium and 5.3 grams of sodium carbonate, all in 1 dm cube versus HCl containing 9.6 cm cube of the concentrated HCl, about 36%, in 1 dm cube of solution. For you to see the likely question, you can chat me on WhatsApp with the number you see there on the screen, and for further guide, just chat me. I'll be there for you. God bless you and remain majestic. Bye for now.
Hi, it's Jeremiah here. I just want to say go ahead and subscribe to Majesty's YouTube channel if you are interested in covalent bonds, theoretical chemical reactions, and things that chemistry has to offer.
Thank you, Sir Jeremiah.